Now over here we're considering left axis deviation because of the left bundle branch getting blocked, right? So because the left bundle branch has gotten blocked, right? So what this means is that the conduction of impulses in the left ventricle via the Purkinje system is 2 to 3 times slower than the conduction rate in the right ventricle, whose Purkinje system, whose right bundle branch is working just fine. What this means is that the right ventricle will become completely depolarized about 0.1 second or more before the complete depolarization of the left ventricle. So when the right ventricle is completely depolarized, a significant part of the left ventricle would have still been in the state of polarization. Polarization is electropositivity, depolarization is electronegativity. They would be a very strong vector that would be directed from the right ventricle towards the left ventricle, towards where the problem lies in the left bundle branch. Alright, and so we have a lot of left axis deviation because of that strong vector. Now if we see via vectorial analysis, we draw a perpendicular line over here to see. So lead 1 is positive QRS deflection, lead 2 on the other hand, this is 3, is negative QRS deflection, as you can see, right? So how would you differentiate this a left bundle branch block from a left ventricular hypertrophy? I mean, in both of them you can see strong left axis deviation. The thing is, because of the problem in the Purkinje system, in this one there will be something additionally seen over here other than these readings. There will be another problem over here. The QRS complex, because depolarization is taking longer to happen, this will be prolonged. Normally it is 0.08 seconds, but if you were to pay attention, this will be longer, right? So it's still here, I think. Basically it's obviously taking a lot of time. Anyways, let's now move onwards to findings of right axis deviation. So right axis deviation happens because of right bundle block. So the transmission of impulses in the right bundle branch in the Purkinje system of the right ventricle will be impaired. So the left ventricle will be completely depolarized far longer than the right, and so we will have a strong vector towards the right ventricle and right axis deviation, this one over here. And if you vectorially analyze it, you should be getting a negative deflection of the QRS complex in the first lead, and in the third lead you should be getting a positive deflection, right? And as you can see, the QRS complex is definitely prolonged. It is definitely more than just 0.08 seconds. It's almost covering 2 big blocks, so it's 0.4 and not 0.08, which is a normal interval.